Hello, my viewer friends. Good afternoon to all of you to this channel. Actually today we will continue our problem practices, right, on intake facilities for public water supply system. I have already described the intake facilities also, and here only so we will discuss the numerical problems, which we will rather practice here, as well as the design exercises as and when this will be needed also. First two problems we have already discussed in our last video. Today we will take up another example, that already the third example also, and this has got a reference to Davis book. I have mentioned already the Davis book also. If you want the details also, publication and all, so then I can share with you. Okay. Now this the third example is about a two cell, that means two. I told that minimum two cells actually for secure design, in the sense that when one is under maintenance or out of operation also, out of use also, then in that case the other one could be used. So that is why here two cell. But remember that I already have told you that in case of two cells actually the cost involvement is much more, because two towers, the similar identical towers are to be constructed also, and the construction cost etc. I have already discussed earlier. Now this actually two cell, as this is the foreign example also, American example also, so that is why they have use the two cell intake towers, so that actually located in a cold climate, reservoir also, that is to be designed. Here it is written, the problem, it is captured also in this video, so you can accordingly that, but just I will discuss the problem statement first. So this is for a winter design. Number 1 point is the winter design. Winter design will have the special significance, winter design. So here actually winter design, the winter flow will be minimum. So for the minimum flow you have to consider the design, because that time whether it is being or it will be able to meet up the entire demand of the population also. So this has to be secured. In the summer time, naturally the flow will be much more than the winter. So obviously that will be able to meet up. So winter is the worst case, right? Because the water will recede. From this actually I told you that the lowest water level will be attained, or will be seen during winter time or so. And the flow rate at that time, this is this flow rate, right? So this is the minimum flow rate for which you have to design. Okay, I repeat this one. I already have told you or discussed this, that this is actually long years past records, statistical this records also you have to collect, so that this actually the intake to be constructed ultimately, that actually should not be insufficient also. In that case actually another intake which will involve quite heavy expenditure. So that is why for intake design I have already discussed this. This incurs a quite, it's a pretty heavy expenditure also. That is why the civil engineer or the engineer concerned also has to design it very carefully also. So taking all these worst cases under considerations also. So here this actually, we have taken that one, the flow. The tower will have 3 ports at 3 different elevations in each cell. So this I have already explained earlier in my earlier videos. I have explained that this actually at different towers, horizontally and vertically also. So these are configured like that, so that at different times, different situation, different ports will be used also. For example, say I will just read it from this one Davis book. So intake ports actually at various depths to allow the changes in water elevation. Please note that at different depths also this is to be provided. That means at different towers and different phases also, I already have discussed, to allow for changes in water elevations and changes in water quality due to wind and wave actions also. So again I will tell you that one of the very important design criteria is to draw the sufficient water, at the same times as best possible that you have to sort of consider. So water quality, quantity as well as quality also is important. So that suppose there is a turbulence also, right? So in that case you have to sort of where turbulence is minimum, in which time you have to open that tower, not tower, the port. So there is a sluice valve also operated by gate valve also. So that actually I have already explained. I don't need to explain it further. Then stratifications and lake turnover also. So that actually we have to consider that at different this one, so that flexibility could be exercised also. That means which phase gives lesser current, which phase will be having less turbulence, and which towers will actually allow sufficient water during worst condition, that also that has to be there considered. And the highest flood levels, suppose when turbulence is on the surface also, then you have to sort of the top intake port also has to be quite down, that I have already told, that sometimes 5-6 meters below the surface, so that the turbulence or debris also do not damage the gate, right? So that way 3 different locations, each port must be able to deliver the design flow rate operating alone. So here one thing, operating alone, that means we will take the design flow of this minimum winter design flow of 6,000 meter cube per day. This has to be sort of that drawn from a single support, so that when this will be operating only alone, right, all our others are closed. Say you have provided this because during summer time when the flow will be sufficiently high also, in that case you can take advantage of other gates also. But at a time, say this one during winter time also, so that one port that alone can meet up the demand when you are not able to operate others for different reasons maybe. So that way you have to determine the area of each port opening. Now let us come to the solution. Let us discuss that. Now for a cold climate reservoir, the intake velocity must be, or rather should be limited should be limited. I am just talking all, I cannot write over the boards because of the space and time also. So that actually should be limited to less than meter per second, cold climate, to avoid ice build-up. Otherwise the ice will be built up. So it should be very less or so that suction that actually will facilitate the ice build-up also. So that is why it must be less than the velocity must be less than 0.1 or so. Using an intake velocity here in the design, we will use that taking the velocity at 0.08, which is less than this one. So the effective or open area that I have already discussed in last two problem also. What is effective or open area also, right? So this is based on this area also. So very simple calculation. So this is Q by V, as you know. So Q design by V velocity minimum. So that would be 6,000 meter cube per day divided by 0.08. We are taking the minimum to be this, and if you multiply just to convert the unit or make it consistent also, that is 86,400 seconds make one a day. So we are making that meter per day. So that is why we have multiplied this by 86400. So to make it consistent with the numerator, so that the area comes with a unit of meter square also. So this should be 0.868 or say 0.9 meter square. Little more than that you are taking for giving an allowance also, right? So this would be the very simple problem, but see that this particular problem in cold climate area, you can understand that number one point is that the design flow must be the minimum or so that when it recedes to the lowest level or so that time also the intake facilities, right, that must be able to meet up the demand of minimum demand of the, or you can say the maximum demand, rather not minimum, maximum demand of the town or the population you are designing for. And the tower also should draw minimum that this quantity or so, say, or you can say the quality water also from that from one single port or so. That way we have designed. So this is here to be understood, and also this is important because Y1 usually what we do, actually we divide by say 3 ports we have provided. Naturally, our understanding is that we will divide Q design by 3 to get that how much sort of Q is entering into or through one port or so, right? So that is why this is to be understood, that when in worst case suppose only one gate is operating also, so in that situation also, that actually intake facility which you have constructed also and operating, that must be able to meet up the town, the population of the city also for which you are designing at the ultimate design demand also, right? And here different tires, you can have different vertically different tires also, horizontally at different phase also, that you can, I have already discussed earlier, right? So that it could be made flexibly in operation also. So this is the that one third problem also. Now fourth problem is just to that this one right. Yes, revise the area. This problem I am not writing because this will take time. So that is why I am just telling you here that so that you can note it. If there is any problem, we can discuss it afterwards. But instead of writing once again, I am just fourth problem about that. Revise the area. Please note, revise the area which has been available here, right? Which had been calculated to be 0.9 meter square or so of each port or so. Revise the area estimated made in this example 3, right? So we will have now the 4, we will write 4, or you can say 3 will keep, but this example say 4. So in 4, revise the area specified for winter condition, made in example 3 above, say, to take into account the area occupied by a bar rack with a clear opening of 4 centimeter and a bar 1 centimeter in width or so. I am coming to this. Okay, so I am erasing this one, this problem. But instead of having the opening area or effective area, now you are trying to find out the gross area which will be required, considering the bar. This one, bar means here I will draw this one, right, for your understanding. So this actually I am erasing this now to create space for this problem. Now the intake gate, it is not left open, right, because the debris and other this one fish and that will be entering into that, right, freely. So instead of that, we will provide the bar this racks also. So that actually will have that the square shaped, this one, the opening, that will be square shaped. So take into account the area of the bar rack, we will provide the bar rack, and the arrangement of one particular, the bar, this one, rack also, that we will have here. This is 4. This is for the, I am writing here for the gross area calculation. So that you, it reminds you that what is this is I am talking about, right? So I am drawing a sketch here, just illustrative sketch also. First thing is that the bar rack will be a square one, right? Right? So all to be uniform, right? So don't think that the only 3 bars always will be there. This is a typical, arrangement or the configuration of the bars. So these are the individual bars, right? And from where we will have the configuration as it is stated that this is the bar, each bar here, this is the individual bars. Individual bars, right? So this will be four centimeter as it is stated in the problem itself, and this actually the bar, the width or so, each bar an individual this bar will have 1 centimeter and 1 centimeter. Okay, so this will be 4 centimeter will be opening through which the water is moving, water is moving through that. So when it will be placed, water will be moving, but here line sketch, here we have drawn, the actual this one. The unit space occupied by a bar and the adjacent opening, so that will be, say, now next bar also will be there. The center to center distance will be 4 plus 1, that is 5 centimeters. That is the average, the center to center distance is that unit space occupied by a bar, means the 2 bars will occupy on an average this space also. The fraction of the area occupied by bar, that means say 1 centimeter is occupied out of 5 centimeters. So 1 by 5 centimeter, that is, or 20%. What does it state? That is, out of total this, say, effective or gross area including bars, right? This is the opening area, it is including that the bar area, the width given. So on an average, if you take this one this way, next one will be also like that, right? So here to here, this will be middle average, so this will be another 5 centimeters, say. So out of this 5 centimeter, the bar occupies, right, only this 1 centimeter or so. Why we are not considering 2 centimeter? Because if we consider 2 centimeter, next this one, this portion will be already included in that, so we don't, so only this one will be there. So that is why actually to have average this one, we are calculating this way. That means 20% of the area, of the whole area, is occupied by the bars only. One single bar or 2 bars arrangements, one opening rather, that we have here, here we have provided, we have shown here the configuration of the bars or arrangements of the bars. So 20% this one. Now on the other way, see that opening area versus this one, that will be 5 centimeter by 1 centimeter, that is 120% or so. That means what we calculated earlier in the last problem, example 3 or so, this was the area. We have to increase that area by 120% of the area opening or the opening area, or the, you can say, the, to get the gross area from the opening area by multiplying that this 20% or so. So gross area, so gross area of a single intake port, right? Intake port will have to be enlarged by 120% of the earlier one, what we have got. So this will be 1.2 into what we have got earlier, that is the opening area. So this opening area has to be increased by by 20%, but this will be the total gross area also. So this will be naturally more than the net area or open area also. So by 20% more also, or 1.1 meter square. So I think it is clear to all of you, right? If you make bar type of this one configuration also, so opening area already you have calculated by directly using the velocity to be the minimum velocity to be allowed through that for on net area basis. So we have calculated earlier in example 3 the net area or the opening area, right? and after that, after we are providing gate also, because we cannot make it fully open also, right? So we have to provide the gate and the bar, this one, right? So entire the cage also will be, pulled up and pushed down also to make it open or close also, right? So that actually, if you consider, then the area of that, right, will have to cover, entire area will have to cover the entire this one, right? So that is why we have increased this by 20%, because as you see here, that bar is occupied on an average on both the sides, half of that, that is center to center. The bar occupies 20% extra to the opening area, and that is why we have multiplied this by 1.2, that is 120% of the opening area, or 20% extra, same. Okay, so that is, that one, I don't know the time, this one, so we can have, yes, another, okay, I think the suction, design of suction pipe also, that also is there. Design of strainer, so we have already calculated. First, this one, the suction backwashing, that we discussed, and the fourth or fifth example, say, right? So that would be, on suction well, right? Suction well, and with this we will complete today's this, design. I should not say design, will come little, after this. Because first you have to know that component wise what we are, and then we will go for the full design also, right? So this I am erasing this one because it is captured, you can see this one, and repeatedly I am telling you that if you do not understand, it is very likely or very common, that you may not understand this one, because in undergraduate, that remember that in undergraduate level we in fact do not emphasize much on the intake this facilities design also, right? Because we have seen in the professional design also that intake this one, they do it this one and checked by us the design part, right? So planning, configuration also, they don't, the professional, or contractor also, who get their designs, done by some professional engineer, and for checking purpose, they are coming to us also. That time, intake works, they do not, furnish the details also. But here I have included, but because many a time, that in competitive examinations, particularly IES also, Indian Engineering Services also, so they are actually, they may give this one, so that, you can, or they can ask in the interview also, right? So that is why, you should have, or you should develop a full understanding about that, how it works, how it is planned, how it is configured, how it is designed, and construction part comes or goes to the structural engineer, or if you yourself can do that, you you can do the structural design part also. And the operating parts, mostly that is actually in the field, that field engineers, they are very much familiar with that, so they actually train the operators also to to educate them, to train them that how the entire this facility is also, so that will be operated also, right? So this is this. And another point which I mentioned earlier, that we told in our last video, that the subscription for registration also. So that actually I will write now this on the board itself, right? I'm still keeping this one because this may be required or will be required in our 2 more designs, examples which will design and numerical problems, which we'll be discussing in the next class, right? So I am erasing this one because this is captured, right? So I am keeping this figure still now, right? This is actually, this is a paid subscription for registration, course registration, right? So for that actually, you know, you have to pay very nominal. We have affordable, reasonable charge. We have actually made, and that actually for individual registration. If a single person registers for that course, then he or she has to pay for one person. I am writing that one person, individual. See, this will be 1999 per person or per subscriber. Okay. Now, what is the advantage of that subscribing to this particular course also? This is actually some of the videos I am for intake or so, you will get, you know, that I mean, you are viewing that one because this has been made public, that means published. So, but you know that this in near future or so, when we will have more, you know, that treatment part, conveyance and all these very many lectures, several lectures we will have this on videos also on this particular channel, which will be made private also. We will not sort of, I mean, make it public, so that the registered subscriber only can view and can sort of, I mean, go for this, can understand or can try for understanding also. And if there is any this one, I mean, problem also, they can go for the one-to-one interaction also. And here this one, if it is, I think the 25% or so, for 20% batch, then in this that will be 40%, that is I think 1199 or so per group of this up to 25%, more than 2 to 25, maximum this one 25, and if it is more than 25 or so, that will further lesser, that is I think this will be 60%, 40% discount per individual. Remember, this is not per group actually, per subscriber or individual in the group, individual in the group, and this will be the same for all these. It is not that, I mean, that the number of videos also will be less or more, or same number of videos throughout the semester we will keep uploading also. You can see the registered subscriber, that will be open to the registered subscriber, so they can see time to time, right? And once they are in touch with us, we will say that okay, this video has been uploaded. You can see, we can provide the link also, right? So with that link you can open that one and see this one. So this is for the per individual, this is 60% discount. Okay, so if we make that, say, if we just, because I from memory I have calculated this one. Now this is 40% discount, so 60% will be charged 1199, and the 40% will be charged 60% discount 799, and for interaction, right, for individual interaction, if you opt for that I have not understood, say, or I will try to understand more with reference to some other problems or so, in that case half an hour video or the Google Meet or I mean Microsoft this one team, or such kind of this one, or WhatsApp also. So we will meet for half an hour, more or less. So for individuals or even the group interaction also, so in that case the individual has to pay rupees 99 per person for such, you know, interactive session also. This is actually all rupees, of course, right? And this subscription will also, we are still thinking that whether we will conduct any examination or not, just to make it, you know, test your, I mean, understanding, and to test yourself also, that where you are, where do you stand also in terms of understanding also. So that will be discussed, this one. But I think I have given you the number, this our WhatsApp number also, that we have given. Again I will give you this one, right? I think I have given this one. So this is the WhatsApp. First one is a 6289 mobile plus WhatsApp, but you use WhatsApp. Please do not use mobile directly also. This is madam's number, Sohini, and this is I, as a mentor of this course, I can be contacted through WhatsApp. I think that email already I have told, that Professor G NY tutorials, right, @gmail.com, right? So that I think I have given, but I'm giving you once again, Professor G NY tutorials @gmail.com. If there is any correction also, as far as my memory goes, I'll see this one, right? Quickly I'll check this one, and I'm coming back within a minute or so. Please wait. Yes, it is absolutely right. So this is email. We could be contacted through mail also, right? So this is all about our, I mean, package also, this course package also. While intake facilities, as I have already just told, that this quite a few number of videos we have already uploaded, which is free of cost. You can see this one, and if you feel, if you judge this, that this would be useful, very useful for your competitive examinations, also UPSC, or I mean blah blah blah, means GATE, then IES, and then state PSCs, so all, for all these examinations also, competitive examinations also. So that actually this course has been tailored and framed also. Thank you so much for your patient hearing. We will meet in the next video. Okay, thank you so much.